Hello. In today's ANSYS tutorial, we are going to do the analysis for this bracket problem using ANSYS Classic. Okay, let's get started. I already have ANSYS Classic opened. So we're going to start by creating the element type. So click on preprocessor, element type, add, edit, delete, and then click add. Okay, I'm going to use plane element because there is no out of plane loading applied on the structure. You can use shell elements as well, for example, for node 181. Okay? But for this analysis, plane element works just fine. Plane element works just fine. Click on solid and then quad for node 182, and then okay. So by default, ANSYS uses plane stress condition, okay, with a unit thickness. But I want to specify the thickness, so I change the element behavior from plane stress to plane stress with thickness. Then click OK, and then close. Next, we need to specify the thickness. So click on real constant, add, edit, delete, add, and then here you see plane 182 because this is the only element that is defined right now. Then click on OK, and then here I specify the thickness of 0.00625. And click OK, and then close it. If you should use shell elements, instead of defining a real constant, you should define a section. Okay, in that case, you need to open sections and then shell, layout, add, edit. Okay, since there is no shell element defined, I am not able to define a section in this case. Okay, this is just to show how to define the thickness for the shell element if you wanted to use a shell element. Okay, so let's close it. Next, let's define the material properties. Click on material properties, material models, structural, linear, elastic, isotropic. Young's modulus is 209. And then Poisson's ratio is 0.3. Okay, and then now we can start creating the geometry of the model. I'm going to create the geometry by creating two rectangles, two circles, and then using Boolean operations to add them. And then I will create a fillet here, and then I add that fillet, area fillet, to the to this main area. Okay, and then I'm going to small two circles here and here, and use Boolean operations again to subtract those two areas from the main area. So go to modeling, create areas, rectangle by two corners, 0, 0, with the width of 0.05 and height of 0.025. Click apply. Second area is at 0 and 0.2 with the width of 0.025 and height of 0.05. And then click OK again. Let's create those two circles. So open circle, solid circle. The first, the bottom one is located at x coordinate of 0.025 and y coordinate of 0 with the radius of 0.025. The second circle, so click on solid circle again. It is located at x coordinate of 0.025, y coordinate of 0.0225, and then with the radius of 0.025. Now let's do Boolean operations to add those areas, combine those areas. Here you see, click on operate, Booleans, add areas. Always look at the message at the bottom left corner of the ANSYS window. It says pick or enter the, so I need to click on areas. Pick or enter areas to be added. So I'm going to select this area, this area, this area, and this area. Then click OK. The areas are added. Let's create those small circles. Okay. So go back to create areas, circle, solid circle. One of the areas, circular areas, is located at 0.025, y0, and radius of 0.00625. And then the second one is located at x coordinate of 0.25, y coordinate of 0.225, and radius of 0.00625. Now we want to subtract those areas from the main area. So click on operate, subtract areas. So the message says pick or enter base areas from which to subtract. So we're going to select the main area, click OK, and pick or enter areas to be subtracted. So let's select these two small circles. Okay. Now we want to create the fillet. We're going to create a line fillet first, and then create an area of creating the area of the fillet by selecting the intersecting lines. Okay, the lines that encompass that fillet, and then we are going to add that area fillet to the main area. Modeling, create. Here you see line and then line fillet. So the message says pick or enter the two intersecting lines. First line and second line, and then click OK. And then fillet radius is 0.025. Okay, we have the line fillet. Now click on area. So under modeling, create areas, you see arbitrary area, and then by lines. First line, second line, and then the third line, and then click OK. So we have the area here. We need to add that area to the main area using Boolean operations. So under operate, Booleans, add, and then areas. Select those two areas to be combined. Click OK. So now we have the CAD model. Next step is to generate the mesh. Okay? We know that under this loading condition, the stress concentration happens around the fillet. Okay? So we need a finer mesh around the fillet, because we need a more accurate result in terms of the results of the analysis around the fillet. Okay, open meshing, size control, manual size, lines, and then peak lines. Let's first pick the line for the fillet, and then click OK. You are going to specify the number of element divisions. So I'm going to use a element divisions, use 10 as the number of element divisions, and then click OK. Let's specify the number of element divisions for other lines as well, because we don't want the element sizes to be ugly or very random. So let's pick these two lines first. I am going to use 15 number of divisions for those two lines. Click apply. Then let's select these two lines. Click OK. I'm going to use 20 number of divisions. Click OK. And then let's specify the number of divisions for these two lines. Click OK. And then use 5 number of divisions. Let's specify the number of divisions for these 4 lines. I am going to use 5 number of divisions for each of those lines, for each of those arcs. Click apply. Then let's specify the number of elements for these 4 arcs. Actually 8. So for these 4 arcs for this small circle, and 4 arcs for the other. I'm going to use 2 as the number of divisions. Click apply. It should be fine for now. Now let's create the mesh. So mesh areas, free, and then select the area and then click OK. We see the warning for one element. Okay, we can neglect that warning for now. Okay, so the mesh doesn't look bad, so we are going to use this mesh to do the analysis. Now let's apply the boundary condition and loading. So go to solution. So analysis type, by default, static structure analysis is going to be done, so we don't need to change it. Define loads, apply structural. We are going to apply displacement on this edge or side of the bracket. So on lines, select those 2 lines, click OK, and we are going to clamp it. Okay? We're going to fix all degrees of freedom. So select all DOF, type 0 here, and then click OK. We are going to apply a line pressure on this top side of the bracket, close displacement, and open pressure on line, and select these 2 lines. The value of pressure that is applied is 26.25 Newton per meters. So after you select those 2 lines, click on OK, and then apply and enter the value of pressure, 26.25. Then OK. Now we can do the analysis and solve the problem. So click under solution, click on solve, and then current LS. Click OK. So you might see this warning because there was one warning regarding the shape of one of the elements, so we neglected that warning. Yes. You should see, so if you did all the steps correctly, you should see this message saying that solution is done. Let's plot the deformed shape first. So open general post processor, plot result, deformed shape, deformed and undeformed shape. Okay, now let's plot the contours of stress. So click on contour plots, element solution, stress, von Mises stress, and then click. Here you see the contours of von Mises stress, and you see that the maximum stress happens around the fillet, and this is where the stress concentration happens. Okay, solution is done. Now let's go back a few steps and improve the mesh, because we don't want to see that warning regarding the shape of the elements. I'm going to clear the mesh first. So go to preprocessor, meshing, mesh, and you see under meshing, you see clear. Okay, and then areas, select the area for which you want to clear the mesh, and click OK. Okay, if you want to see the areas, again, here in the command window, type a plot. Okay, in order to improve the mesh, so let's go to size control, manual size, line, and pick line. So when I selected this line and this line, I used 15 number of divisions. Okay, but over this line and this line, those number of divisions is distributed uniformly. In other words, the length of the elements here and here are going to be equal. If I want to use a smaller sizing for the elements close to the fillet compared to this side, okay, which is far from the fillet, I need to specify the spacing ratio. So I'm going to use the spacing ratio of 0.5 and then click on apply. Here you see that the divisions are smaller here compared to this region. I'm going to do the same for this top line and left edge. Pick line and then select those two lines and then click on OK. Here I used 20 number of divisions, but I didn't specify the spacing ratio. So 20 again and 0.5 here. Then click on OK. Okay. So now let's do the meshing. Mesh, free, select area, and OK. See, it didn't show the warning again. Okay. Let's do the analysis again. Solution, solve, and then current ls. Right. All right. That's it for this ANSYS tutorial for analysis of the bracket problem.